Hi, my name is Bill Papoon. I am managing partner at Construction Science. We provide quite a few online and in-person Primavera training sessions, and those training sessions are scheduled through our other website, primaverascheduling.com, which you're seeing on the screen. When people come to us, they often don't have a lot of the theoretical background in scheduling. And so today we're going to take a look at probably the most important thing when it comes to scheduling, the critical path. The critical path determines float for all other activities, because I think, as you can imagine, the critical path would not have any float. But why exactly doesn't it have float? Well, there's two reasons, and it has to do with the forward pass and the backwards pass calculations. In school, all the way back in 1981, I studied this method of calculating the forward and the backwards passes manually. Today I'm going to walk you through this. It's a little bit more complicated in a large network, so we're going to start off with a very simple network. Now I'm going to show you the results of the schedule first. So we're looking at something here with not too many activities, and I don't want to distract you with descriptions, so you can see that the descriptions are actually quite generic. And we can see that some of the bars are red, others are green. And of course, most of you know that green means non-critical. And then you see the float numbers. We see anything from 0 to 5 to 15 days. So today we're going to calculate those float numbers ourselves. Now, when you're looking at a traditional Gantt chart, this can be a little bit difficult. So actually what I did is I switched over to the network diagram view. If you haven't looked at this before, I encourage you to play with it. One of the big advantages of the network diagram, it's not time scaled. So in my original network, when you're looking at it as a bar chart, some of these activities have very short durations. The very first activity is just 1 day. And that's hard to see on a network diagram that's not otherwise time-scaled, because the time scale will shrink down the durations relative to the other activities. So again, going back to the more traditional Gantt chart, you can see that activity A is almost non-existent. It looks a lot like a milestone as a practical matter. So when we switch to this network diagram, and we remove the time scale, it gives every activity equal weight. So we're going to look at running the forward pass first. And here we are. Here's the forward pass. In the upper left-hand corner of each box is the activity ID. In the upper right-hand corner is the duration. Down below, I've put in this bottom row to indicate the float calculation. I shouldn't say the float calculations, but the forward numbers. And you'll see that I've got a division here. I'm using the slant to indicate that there will be another number plugged in a moment. So starting off, we're at day 0. At the end of this first activity, which only has a 1-day duration, well, that'll be day 1. That then will kick off other activities that activity A is linked to. You can see that activity C and activity B both follow activity A. So activity C starts on day 1 and activity B starts on day 1, the end point of the activity in front of them. Now I know some of you are going to say, wait a minute, this would be day 2 because this will be one entire day. Well, technically that's correct. When you're using a calendar, the calendar most likely would say that this is a different day, that if activity A ended on Monday, activities B and C would start on Tuesday. But that's not always true. And for the forward and backwards pass calculations, you'll see why we don't want to do it that way. But consider that you could have an activity that starts at 8 o'clock in the evening and finishes at 4 a.m. So that's an 8-hour task. In that particular situation, you could have an activity that finishes at 4 a.m. on Tuesday, and its successor would start at 8 p.m. the very same day, not the next day, I know a lot of us are used to the idea of thinking that something always starts the next day, but that's not always true. It all comes down to the calendar. So as we follow this network through, we see that day 1 kicks off activity C. It's an 8-day duration, so at the end of this activity is day 9. Day 9 then kicks off activity E, and activity E has an 18-day duration, so it finishes on day 27. Activity I, of course, starts on day 27, and with a 20-day duration, finishes on day 47. Activity L starts on day 47, has a 16-day duration, so it finishes on day 63. And the final activity along this path, activity M, starts on day 63, has a 7-day duration, so it finishes on day 70. In a large network, you have to consider every possible path when you do the forward pass. So naturally, there's another path we would have to follow that goes from activity A to C down to activity D and across the middle with the same terminus, activity C. But you can see here, obviously, as we come down here, we're getting smaller numbers. We're on day 1. We finish on day 9. Activity D will start on day 9, has a 10-day duration, so it finishes on day 19. Now keep in mind, this is not time scaled, so even though this is day 19, you can see that it basically lines up with day 27 above. Day 19 on activity G for its start, 19-day duration, it finishes on day 38. Activity H starts on day 38, 10-day duration, so it finishes on day 48. Now you can see that this path is clearly not as long as the one above it, because here we are on day 48. If we had no other activities to worry about, we could say that this project is done on day 48, but that's not true. Obviously, we have another activity out here starting on day 63 and finishing on day 70. The dotted line is very important here. In a Primavera network, and that's what this is, of course, in Primavera, when you see a dotted line, it means non-driving relationship. Activity H, finishing on day 48, is obviously a lot sooner than activity L. Activity L is the driving relationship, indicated with a solid line, and in this situation, because it's also the longest path of construction, it's a red line. And you'll notice that all of the boxes along the critical path have red outlines. Across the bottom, once again, you can see that as we add up the numbers moving across, eventually we get to the end of activity K, and activity K will finish on day 58. But again, day 58 is sooner than day 63, although it is later than day 48 for activity H. So you can see that this path is actually longer than the one through the center, but slightly shorter than the one across the top. But that's all you can tell with the longest path. That right now we have the longest path of construction. It's a total of 70 days, but now we need the float on the activities, and the float is determined by the backwards pass. So let's switch over to the backwards pass. You'll notice that there's numbers filled out in the lower left-hand corner of the box. Now there's 2 numbers. So let's see how this works. At the end of activity M, we know that that was day 70 on the forward pass. That's the first number. We also plug that in over here as we start the backwards pass. We take 70, we subtract the duration of that activity, we come up with day 63, which has been plugged in here next to the other 63. So as we're working backwards, we're subtracting durations, whereas on the forward pass, you're adding durations. So here's the thing. When you see the same number side by side, it's sort of like saying 63 minus 63 is what? Well, it's 0. That's why we have 0 float. And as we move backwards through what we knew to be the longest path of construction, that should always be the answer. So here we are, day 63, working backwards. That's also day 63 here. We subtract 16 days, we get 47, which matches the number we got moving forward. Again, 0. So we move over to activity I. Day 47, working backwards. We subtract 20 days, we get 27, which matches the number that we got moving forward. Again, 0. And that will work all the way back through what we recognize as being the critical path of the project. Critical path, longest path, essentially mean the same thing. Now, it gets a little bit more interesting when we move off the critical path and we're looking at something else. So we have activity M with day 63, and that'll also be day 63 here at the end of activity H, because in theory, activity H could finish on day 63. We subtract the 10-day duration for activity H, that comes out to 53. All right, there's a difference. 38 versus 53, you can see that there's a difference. Likewise, we can see the difference here at the end of the activity. Day 48 versus day 63. The difference is 15. That's the float on this activity. Likewise, when we move backwards to activity G, we're on day 53 at the end. We subtract the duration of 19, we come up with 34. Day 34 versus day 19 is a difference of 15. Again, 15 days of float. On activity D, we know that it can finish on day 34. We subtract the duration of 10, we get 24 days. But the difference between the 24 and the 9 is 15 days. So this string of activities right here, they all have 15 days of float. But at that point, they merge back to the critical path, and the critical path has a smaller number, so we work off of it. This will not affect activity C. Then we see the path across the bottom. We know that 63 is the beginning of activity M. That would also be the end of activity K. We subtract 14, we get 49. The difference between 49 working backwards and the 44 that we derived working forward is 5 days. And naturally, we see the same thing at the end of activity K, a difference between 58 and 63, 5 days. And we work backwards. Activity J can finish on day 49, but the number working forward was 44. So there's a difference of 5 days. We subtract the duration from 49 of 11. We come up with 38. And again, we see the difference of 5. Activity F can finish on day 38, but moving forward on the forward pass, we came up with day 33, a difference of 5. We subtract 12 from 38, we get 26. Again, it's a difference of 5 versus the number we came up moving forward. Then activity B finishes on day 26, or it could finish on day 26, but on the forward pass we came up with 21, so a difference of 5. We subtract 20 from 26, we get 6. Again, there's a difference of 6 on the backwards pass versus 1 on the forward pass, so we have 5 days of float. This activity likewise merges back into the critical path, and so the smaller numbers take over here. Let's go back to our Primavera schedule. Let's switch it to the Gantt chart, and we can see the float numbers, the 0s, the 5s, and the 15s. But again, it's hard to appreciate these numbers if you haven't seen it in a different light, where you don't understand exactly how Primavera determined 1, the critical path, which is the forward pass, and how it calculated the float, which is working backwards. And that's pretty much it. As you can imagine, there are complications when you're using, say, a start-to-start relationship or a finish-to-finish relationship, because all of these are drawn, as you can see, as finish-to-start. And calendars can certainly make a difference. If not all of the activities share the same calendar, that can certainly make the float calculations a bit different, because float is determined by the activity calendar. So each activity has a float value, but it's determined by the calendar on that particular activity. So an activity with a 7-day calendar might have 7 days of float. An activity with a 5-day calendar could have 5 days of float. And essentially both of them have 1 week of float. It's just expressed in a different manner. If you have any questions, feel free to visit our website, primaverascheduling.com. And as I mentioned before, we have classes weekly online or in our offices in Sacramento, California, and I invite you to join us if you can. Thank you.